Okay, next one. Starting at 31. This one we got the same thing. Also, what I learned that if possible, you're supposed to start closest to. These are called substance, like closest to the substance, like the branching out parts. So if we start over here, 1, 2, 3, 4, 5, 6. That's 6 away from the start. But if you start over here, 1, 2, 3. It starts at 3. So that means we will have 2 here. Remember, we have to separate our ethyl and our methyl. Remember, the ethyl is always first, so ethyl and our methyl. And then remember what kind of compound this is. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So it's good. It's gonna be an octane. Okay. Next, another thing is that it likes to you start counting closest to the double bond. So our start's gonna be over here because it's close to the double bond from over here. So we have 1, 2, 3, 4, 5, 6. So it's hex. Remember, this signifies a double bond. If there was like a third line, that signifies a triple bond. And double bonds are always hexene. And then with hexene or with enes and then the ines, you put a number where the double bond starts to signify like where the double bond is on the structure. So we put a number where the double bond starts on the chain. So the double bond starts at 1, 2. It's double bond starts at 2. So I put a 2 in front of it like that. Okay. Same thing here. This one's stupid. You start from here, so we have 1. Anytime there's not like a number or like a letter visible, you know that there's a carbon there. So 1, 2 carbons. 2 carbons is ethane. So now we're working with ene here, because ene is always the double bond. And then we have 2 chloros. So both of our chloros are at 1, technically. So we can put 1, 1 chloro. Do you need the dichloro? Oh, wait, this should be the in front. 1, 1 dichloro. Yeah, just like that. That one was confusing. Next, we have this one. Remember, we start closest to the double bond. So we have 1, 2, 3, 4, 5. All right, so we start at 5. Our 1, 2, 3, 4, 5. So we're working with pentene, remember, because of the double bond. We put where it is, where the double bond is. Double bond is at 1, 2. So we put 2 in front. And then you always put the ethyls and the methyls in front. So remember, our ethyls start first. So 1, 2, that's not an ethyl. 3, 4. Those aren't ethyls either, so we have no ethyls actually. And then put where our methyls are. So we have 1 ethyl at 2, and then 2 ethyls at 4. So we have 2, 4, 4, like that. And then it's going to be 2 or 3 of them. So we're using tri, and then trimethyls. Just like that. Next. Okay. We're going to start over here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that means we have octene, because remember the double bond. And then we count where the double bond is. So 1, 2, 3. Double bond is at 3. And then where this methyl is. 1, 2, 3, 4, 5, 6. So 6 is where our methyl is. No, mine is the other way around. Okay. 1, 2, 3. It always wants to be closer to a substantive than it wants to be to the, or is that not true? I just put, oh no, okay, no, I was right. It always wants to be closer to the double bond than it wants to be the substantive. Okay. All right, next here. So we have to learn about cis molecules and trans molecules. Okay. Cis molecules are where a is where like a certain atom is on the same side of a double bond. So like this, the bromines, they're on the same side. They're both up compared to the double bond. But on this one, they're crossed. They're not both on the left, they're not both on the right, they're diagonal each other. So they're trans. We look here, we're looking at their configuration. So what this tells us is, since it's not telling us, we have to look for since there's not multiple chlorines, we're not looking at if the chlorines are trans. We're looking at if the two hydrogens of the double bond, remember there's gonna be hydrogens here and hydrogens here, are, if they're cis or they're trans. So if they're cis, they're gonna be on the same side. Remember, this hydrogen is going this way, this hydrogen is going that way. So they're opposite to each other. They're not, one's going on this top side, one's going on this bottom side. So that's telling us that this is trans. Next, now we're drawing heptines. So first, do the hep, which is 7. So do 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 7. And then remember, the ein means that we are with a triple bond. So this is telling us our triple bond is going to be at the first carbon. So we click on our first carbon right here, and we add a triple bond like that. It's going to change shape. Don't worry about it. Okay. Now, we're adding methyls and then also octines. So, first octane, so it's 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8, okay? And then, first this ein tells us there's a triple bond, and the triple bond is at 2. So, triple bond 1, start here, 2. So we have the triple bond here. Now, we also have to add 2 methyls. So we add a methyl at 4. 1, 2, 3, 4. Add a methyl. Remember, methyl is just a line. And a methyl at 7. 4, 5, 6, 7. 7 right there. Okay. Next, we have this one. When you're looking at this, the 2 sides of the bond are going to be a carbon. So carbon is going to be over here, carbon is going to be right here. So we start 1 carbon, 2, 3, 4, 5, and 6. So 6, we have hex. Remember, triple bond, hex, ein, like that. We first have to say where the triple bond is. Triple bond is at, it starts at 1. And then remember before it, so we have 1, 2, 3. So we have 2 methyls here at 3. So 3, 3 methyl, like that. Oh, I forgot. Dimethyl. Like that. Okay. Again, we're starting closest to the double bond, or the triple bond. So we have 1, 2, 3, 4, 5, 6. So 6, we have hex ein, because the triple bond. Tell us where the triple bond is. It's at 1, 2. And now we have a couple of things to add here. First we have a chlorine, and then also we have a methyl. Remember, it always goes in alphabetical order. So we're gonna add where our chlorine is, or our chloro. When we're working with things other than lines, it's usually gonna an O added to the end. So first tell us where the chloro is. It's at 1, 2, 3, 4. So we have chloro 4. And then where the methyl is. 1, 2, 3, 4, 5. We have 1 methyl at 5. Like that. Alright. Next we have this. We have a methyl. And then we're working with cyclo. Whenever you see the word cyclo, it means that it's going to be close. It's going to be like a close shape. It's not going to be like a direct line like this. It's going to be close shaped. So, since we're working with pentene, our shape is going to have 5 sides. Like this. You can just click at the bottom. So, you now have a 5-sided shape. This tells us pentene is going to be a double bond. And a double bond is at 1. So, since there's not really like a place to start, wherever you place the double bond, that's your number 1. So, double bonds here, we have 1, 2, 3. So, 3, we add a methyl, 3, and then we also have a methyl on 4, like that. So, that'll give us our shape. It looks a little weird, but. All right, next. Working with cis. So we're working with cis here, and then we have methyl, and then hexene. There's no cyclo, so it's a straight line again. So hex, just do 6, 1, 2, 3, 4, 5, 6, 2, 4, 6. It's telling us our double bond, because the ene is at 2. Put the double bond there. We have a methyl at 4. 1, 2, 3, 4. Methyl there. However, what this is telling us is that these 2 hydrogens on the double bond, since it's cis, remember cis is same side. So these 2 hydrogens have to be on the same side. But this one's on top, this one's on bottom. That can't be right. So reset, we do this all over again. We have to structure it in a way where the 2 hydrogens are on top. So if we do it like this, 1, 2, 1, 2, 3, 4, 5, 6, like this. And then we put the double bond on 1, 2, 1, 2, 3, 4, like that. So now you see here, the hydrogens are both on top compared to the double bond. And that tells us that this is cis, and everything else is the same. So that's how you figure out, that's how you write a cis down. Okay, next we have this. So these are the benzenes. Right, that's what they're called. And the benzenes. I forgot what's going on. So this is the benzene. So benzene. Remember, if it's a hexagon and it has these 3 lines, this tells us that's a hexene or a benzene. And then with these, you just add whatever's being connected to it to the front of its name. So we have NO2. Remember, that is nitride. And nitride, remember, usually just gets replaced with an O. So it's nitro, like that. All right, we're gonna cut off here.